Hello and welcome in the next video where we'll discuss the previously assigned tasks. Let's focus now on exercise 1. There were 2 tasks and I think it's better to show a solution to the second one because I think it might cost you more troubles. So let's see what is the circuit here. We have a single resistor in the upper part, then 2 resistors right here, and a single resistor here, and we have 2 voltage source. So let's mark them as follows. Okay, and let's see what do we know. So this resistor has 1 ohm resistance. This is 3, 2, 4 ohms, and moreover we know the current flowing through this resistor, which is 3 amps, and the voltage here is 20. Okay, so what we should do is to determine the current through each of the resistors. We already know the first one, which is this one. Knowing the resistance and the current, we can calculate the voltage drop right here. So this is simply 3 times 4, which is 12 volts. And what we also know from the Kirchhoff's law is that in this loop, so in this one, the sum of all voltage drops must be equal to 0. Okay, so we know that let's call this UR4, and this is V2, this will be V1, and this is UR2. So what we do know is that this voltage drop plus this voltage drop must be equal to this one, okay, because this is in the opposite direction. So we can easily calculate UR2, which is voltage drop on the resistor of the value 2 ohms, will be equal to 20 minus 12, okay, which is 8 volts. So this is the voltage drop on this resistor. So we know that we have 8 volts right here. So from this and from the resistance, we can calculate the current that is flowing through this resistor. We know that the current and the voltage drop are in the opposite directions, so we have current flowing in this direction because the voltage drop was like this, and the value is 8 divided by 2, which is 4 amps. Okay, so we now have solved the first loop. Now we can use another Kirchhoff's law, which is the current Kirchhoff's law, and it states that when we have a node, incoming currents must balance the outgoing currents. Okay, so if we have 4 amps incoming to this node, there must be also an outflow of 4 amps. So we currently have only this value calculated or given. So this let's call it 3 because it's flowing through the resistor of 3 ohms. I3 is simply 4 minus 3, which gives us 1 amp. Now we have current and the resistance. So again, we can calculate the voltage drop. It's simply 3 times 1, which is 3 volts. Okay, so now we have almost completed the second loop, which we can now complete with the calculation of the voltage source. So we can calculate exactly how many volts there are. So again, the same principle, all voltage drops must balance out. So we have 3, 12 in the opposite direction. So we expect this voltage V1 to be the difference of this and this one. Okay, so 12 volts minus 3 is 9. Okay, so we have now solved the problem solved the problem B, which is the voltage of the battery on the left. What we are missing is the current flowing through this resistor. We can again use the same principle. So we have third loop, and the voltage drop on these two resistors is respectively 3 volts and 8 volts. They are in the same direction, so we know that this voltage drop will be 11 volts. And now let's see what direction this will be. It must balance out these two. So if we have loop in this direction, we can see that this voltage drop and this are in the opposite direction. So this voltage drop must be the same direction as the loop we defined. Okay, so this is 11 volts in this direction, so the current goes this way. And the current is simply, again, 11 volts divided by the resistance, so 11 amps. We have almost everything to calculate the last part, which is the power delivered to the circuit by the battery on the right. Power will be simply voltage times the current. We know the voltage, we don't know the current yet, but we have note here that we know that outgoing current here is 11 amps and 4 amps, which was calculated before. So again, we know that the incoming current to this node must be equal to the sum of these two, so 15 amps. Now we can calculate easily. 20 times 15 is 300 watts. Okay, so this is the solution to this problem. I hope you were able to solve it on your own. If not, then I hope that this video will give you some tips and explanation to how to solve such circuits. The basic approach is to find the loops and to balance the voltage in case of loops, or find the nodes and balance the currents.